Okay. So in STM32 microcontrollers and ADC peripheral, there are some important concepts of the types of group in ADC and the conversion modes. So first of all, understanding and getting to know about the groups, concept of groups. So there are two groups in ADC peripheral we can have: regular group and injected group. Now what exactly are these groups? These groups are nothing but you can take it as that we can configure a particular number of ADC channels in respective groups, in regular group and in injected group. Now let's say in regular group we have configured 5 ADC channels, and in injected group, as it says, it can compose maximum of 4 conversions, and injected group can have maximum of 16 conversions. So let's say in regular group we have configured 5 ADC channels, and in injected group we have configured 2 ADC channels. So now a regular group conversion is the same like any other microcontroller ADC way we have, like in Arduino. So we just configure the channels and then their conversion starts. Same way as in the regular group. There is it's not a very much different thing. But what happens in injected group, if we have configured the injected group and its core, and now both of these groups will be having their own external event and their own the sampling times. Okay, so now let's say a regular group conversion is going on from channel 1 to channel 5, and an external event has occurred for the injected group. Okay, so at that time, let's say 2 conversions to channel 1 and channel 2 have been converted by of regular group. So instead of then converting the channel 3, 4, 5, it will first get into the injected group channels 6 and 7. It will first, after 1, 2, 6 and 7 will be converted, and then it will resume from 3, 4, 5. So if you can say injected group is like an interrupt to a regular group. If its injected group trigger event occurs, then the regular group conversion will be stopped, and the injected group number of channels which are configured in it, those will be converted. Okay, so that is the concept of regular group. Okay, now the regular groups and their order in conversion sequence must be selected in ADC_SQR registers. Total number of conversions in the regular group must be written in L bits of ADC SQR1 register. So as I have said, regular group has we can configure up to 16 conversions. So we have to configure that how many conversions, how many channels will be there in the regular group. So that we can configure from the L bits of the ADC_SQR1 register. Okay, and in the regular channels, the regular group channels and their order in the conversion sequence we can also configure. That is, now let's say there are 5 channels, as I have said, channel 1 to channel 5. So we can also configure the order in which their conversion will happen. So if I want that like channel 3, channel 8, channel 2, channel 2, channel 0, channel 2. So the order of this conversion of the channels, we can also configure that first this channel will be converted, then this channel will be converted, then this. So that we can configure from the ADC_SQRX registers. Okay, and same way is for the injected group also. It can compose up to 4 conversions, so we can configure the total number of channels or the conversions from the L bits of the ADC_JSQR register. J stands for jected. Okay, and the injected channels and their order we can also configure, just like the in the regular group I have told you. We can here also configure the sequence in which channels configured in the injected group will be executed. Okay, will be converted. Okay, and that sequence will be decided from the ADC_JSQR register. About these registers we will get in detail when we will get into the register descriptions. Then comes the types of conversion modes. So in ADC peripheral, in STM32 microcontrollers, there are 2 conversion modes: scan conversion mode and the continuous conversion mode. In the scan conversion mode, it does the ADC conversion only once. The mode is started either by setting the AD-ON bit in the CR2 register or by external trigger. Okay, so like in single conversion, the ADD does only one conversion, that is, it will start from channel 1 to channel 5 and then it will stop. Okay, whereas in the continuous conversion, the ADC conversion starts another conversion as soon as it finishes the one. Okay, so like this mode is started either by AD on bit in the CR2 register. So like after the channel 1 to 5 are converted, then it will again start conversion from channel 1 to 5 again, then again from 1 to 5. So in continuous we can say it's in a kind of a while loop. Okay, keep on executing, keep on converting the configured channels. Okay, whereas in single conversion mode it does the conversion only once. So let's say when we have just on our system, we have to check the voltage and current values. So in that case, just at the system reset and the system initial stage, we want to check the values. So in that case we can use a single conversion, only convert the ADC channels at once. But now let's say we have to monitor the voltage and current readings of a system continuously. Okay, so in that case we will use the continuous conversion mode, in which again and again after channel 1 to 5 are converted, then again channel 1 to 5 are converted again and again. Okay, so if a regular these are the types of conversion modes. Now if a regular group channel is being converted, then the converted data is stored on the ADC underscore data register. This is the data register of the ADC, where we will get the 12-bit binary value, okay, of our converted value. AOC end of conversion flag is set. As I have told you that AOC end of conversion, it's a kind of a flag that will be set after every channel is being converted, whether in regular group or injected group, and then interrupt is generated for if the AOC bit is set. Okay, if injected group, in the injected group, same converted data is stored in DRJ register. For regular we have data register, for injected channel we have separate register DRJ1. Okay, and for its GOC end of conversion injected flag is set. Okay, so like both of them have separate data register, separate flags, and an interrupt is generated. In continuous conversion also same things happen. If a converted data is stored in the 16-bit data register, end of flag is register is set, and same way out and same for. Now comes the analog watchdog is another feature ADC peripheral, in which what we can have, we can configure the highest threshold and the lower threshold of our ADC value. So let's say if our ADC value is less than threshold, this minimum value, or more than this maximum value, then ADC will jump into the watchdog event. Okay, so like this can be used for monitoring the ADC peripherals between a particular bandwidth or a minimum and maximum values. Okay, so if the values are in that guarded area, then it's okay, keep on doing the same thing. And if it falls below or above this guarded area, then it will jump into the watchdog. Okay, so that is what is the basic view of the analog watchdog, but we will not use the analog watchdog in first in this video for this basic driver. Okay, then comes the scan mode. Okay, so as if now we have get to know about two groups of our the two groups in ADC, then the types of conversion in ADC. True groups are regular and injected group. Conversion is continuous conversion or the single conversion. Okay, continuous conversion or the single conversion. Now, so that's it for now. Like the video, subscribe the channel, and press the bell icon to get notified for new videos, and share it with your friends.